The other type of collision, we are still in collisions where we are saying that when bodies collide, we are saying that the momentum is conserved, provided no external force act on that body or on those bodies. And we are saying that when bodies collide, they may fuse and move together in the same direction with the same velocity. Again, they may separate and move in the same direction. Again, they may also separate but move in the opposite directions. So we look at number 2, the other type of collision, which we are calling the inelastic collisions. The inelastic collisions. Inelastic collisions. Now, with the inelastic collisions, we only have momentum being conserved, but the kinetic energy is not conserved. So this is a case whereby only momentum, it is only momentum is conserved, but kinetic energy is not. Conserved. Only momentum here is conserved, but kinetic energy is not. And in this case, mostly, I may give you an example of a lump of plasticine colliding with another one, and then they fuse. Let's say we have a lump of plasticine here, and we have another one. This is plasticine. We have two masses. Now, when they collide, let's say this was moving towards this direction, and then this one was approaching the other one. And when the two collide, they will be attached to one another. This is after collision. After the collision, they will start moving together. These two will move together. Let's say if this velocity was more than this, then it means that they will start moving towards that direction. That is after collision. In this case, therefore, you will find that once they collide, and we have seen that this velocity being more than this one, they'll move in this one direction, that is towards the left. And therefore, we can say that in this case of the lumps of plasticine colliding, then we can say that this case is a perfectly inelastic collision. This is an example. The collision of lumps of plasticine is an example of perfectly, it's called a perfectly inelastic collision. Inelastic collision. It is an example of perfectly inelastic collision. So we are saying a perfectly inelastic collision is a collision whereby only momentum is conserved but kinetic energy is not, and then we are saying that the two bodies move together after collision and they move in one direction. So collision of the lumps of plasticine is an example of the perfectly inelastic collision. And I would like to give you the conditions or the properties of this perfectly inelastic collision. So these properties are properties of perfectly inelastic collision. The properties of perfectly inelastic collision. One property of this type of collision, or one thing that will tell you that the collision is perfectly inelastic, is that number one, the sum of the total mass of these bodies will be the sum of their individual masses. That is, if this body is having a mass m1 and the other one mass m2, when they collide together, because we are saying that they will fuse and move in one direction, the total mass will be the sum of their individual masses. So this body will become one. Initially there were two, one with mass m1, the other one with mass m2, but after collision they will become one body, and therefore the total mass, number one, the total mass is the total mass is the sum of their individual masses, is the sum of the individual masses. That is one thing that should be noted, that the total mass of this whole body will be now the sum of the individual masses. That is to say, if this body 1 had a mass of, let's say, 5 kilograms, and the other one had a mass of 3 kilograms, it means that the total mass is the sum of their individual masses, which is 5 plus 3 to give you 8 kilograms. That will be the mass of the whole body. Then number 2, something else that will tell you that the collision is perfectly inelastic is that after collision, the bodies will move in one direction and they will have a common velocity. After collision, the bodies move at a common velocity. When these two or more bodies collide, when we have a lump of plasticine colliding with another one and they are forming a big body, we are saying, number one, that the total mass is the sum of the individual masses. Then after collision, these two bodies or these small bodies will move at a common velocity, because now they are moving in one direction and they are together, they have already fused together. Then it means that they will move at a common velocity. So after colliding, we are saying that they fuse, or we say they coalesce. The bodies coalesce. That is, they move together. After collision, they fuse and move together, or they coalesce. Then we are saying that for the perfectly inelastic collision, the total mass is the sum of the individual masses, and after that collision, the bodies move at a common velocity. Now we have seen for the inelastic collision, that is for this case, the perfectly inelastic collision, we are saying that kinetic energy is not conserved. And you may be asking yourself, why is kinetic energy not conserved? One, this kinetic energy is being lost. Some energy is lost. When these bodies collide, there may be some deformation, change in shape. For example, if you have a round plasticine and another one which is very round, when they collide, you may find that the shape will change. So there will be what we call the deformation. So we say, this is deformation. So we say that the energy, the kinetic energy is lost because one, some energy is lost during the deformation. Again, when the two collide, there may be production of sound, and sound is a form of energy. Therefore, some energy may also be transformed to sound. Again, some energy may also be transformed to sound. Sound energy, and also there may be production of light. So also some energy may be transformed to light. So this is also very examinable, where you are asked why the kinetic energy is not conserved. So we are saying in this kind of collision, the perfectly inelastic collision, kinetic energy is not conserved because number one, some energy some energy is lost during deformation, during the deformation of the bodies. Again, we are saying that B, some energy may be transformed or is transformed. Some energy is transformed into sound, heat, and light. And we know all these are forms of energy. So we are saying that some of the energy is lost during the deformation, the changing of shape. Then some energy is transformed into sound, heat, and also light. And those are the two types of collision. Elastic collision, whereby both momentum and kinetic energy are conserved. Then we have also talked of the inelastic collision, whereby in the case of perfectly inelastic collision, we are saying that only momentum is conserved. And we are saying that the common properties of the perfectly inelastic collision is that the total mass is the sum of the individual masses of those bodies. Then after collision, the bodies move at a common velocity. We are also saying that kinetic energy is not conserved because one, some energy will be lost during the deformation. Some energy also is transformed into sound. Sometimes there may be production of heat and production of light. And those are the types of collision that we have. So during this lesson, we have covered the law of conservation of linear momentum, and we have seen that it states that for a system of colliding bodies, the total linear momentum remains constant, provided no external forces act. Then we have also looked at the types of collisions, the elastic and the inelastic collision. So I'd like to give you an exercise. During the next lesson, we'll now get into numerical calculations for the types of collisions, and also we'll apply now the law of conservation of linear momentum. So I'll give you some exercise, especially now on stating exercise. So question number 1, state the law of conservation. State the law of conservation of linear momentum. That is number 1. Then question number 2, we have the following. Again on the law of conservation of linear momentum, we have distinguish. That is number A. Distinguish between elastic and inelastic collision and inelastic collision. So you distinguish between the two. Then part B of that question, we have the following. Part B, state the forms in which kinetic energy is transformed during an inelastic collision. Then finally, number 3, give 3 examples of cases of perfectly inelastic collision. collisions. So you give 3 examples of the cases whereby we find the perfectly inelastic collisions. Let's meet during the other lesson so that we can do some more questions, especially now the numerical bit. Thank you.